recordings related document. Okay, fine. Let's get started. So, what is the concept of circuit breaker? Why do we need it? What is the advantage with that? Let's discuss everything one by one. So here we go to the drawing board. Okay, so we are talking about microservices. So there are multiple services available, right? So this is one microservice, this is another microservice. Let's say processing service and Stripe provider service. So in a microservice based environment, it is very much possible that many number of services can call this destination service, right? That kind of communication is very common in many projects. Microservices call each other. Okay, and the basics of programming, right? So we will be having, let's say, some database. Okay, or this guy might be working with SQL database, no SQL database. This guy might further, right now it's already doing Stripe call, so making external service call. Okay, this guy might connect to whichever other places. Let's say, for example, it is connect to OpenAI APIs or any other models. Next, it might be connecting to Redis. So the point to be told is, when you are doing programming, your service might interact with lot of other systems, or there could be n number of other services of AWS. Okay, so in AWS there could be SQS mechanism, there could be S3 buckets. So again, your service is connecting to that also. Plus, you will have a lot of your own business logic. So the point trying to tell is, okay, when we do project development, depending upon your features, you will have to do a lot of coding. And it is quite possible that if some other systems are also performing in a slow manner, that will take more time for you to complete the business logic, right? So if these other systems are behaving slow, you will also take more time to complete. Now just imagine if this service is so much loaded because it has to do so many things, and still more and more people are continuously making API calls to this service. Okay, what is going to happen? Just imagine the service is already slow and these guys are all calling this service. So a point will come where this service is not going to process all these incoming requests. So we need to understand, whenever a service is running, this service is going to have some number of threads for processing. So service is not magical. Service will have number of threads, nothing but how much CPU percentage it can occupy. So 100% CPU. Next, how much of memory RAM it is going to occupy, how much of these threads are available. So the point to discuss here is, when this service is running and all of this thing is going on, it might end up all of its incoming threads, or it might end up CPU is really piling up because it is running some logic continuously and not able to get back, or your memory is really occupied. So this is a very common behavior in microservices. Okay, because every service is supposed to do a lot, so they might be doing a lot of things, and in that they might slow down. So this is our major concern. The destination service is already overloaded and performing in slow manner. Now what is going to happen, guys? If somebody is trying to connect to this, maybe they will start facing some network problems, maybe some timeout, or their threads are only waiting for response, they are not getting the response. Nothing but, if this service is not working properly, this remaining part of the system will also start failing. Okay, so there is an impact. So our first case is, destination service is already overloaded and performing in a slow manner. And then when invoker services are calling such affected destination services, Okay, the invoker services will also face issue. Just imagine network timeout. This service is calling this guy, and they are supposed to then get a response within 60 seconds. So for 60 seconds, your invoker thread is also occupied. Just imagine. So this guy is performing slow, but now this guy is waiting for 60 seconds. Okay, once you give me the response, then only I can do something. And just imagine when other people are calling and all of your threads are now waiting for a long time, basically this service is also going to become slow. So what can happen? This is a ripple effect. If one service is affected, it will lead to other services also being affected. It is practically possible. Okay, so let's try to understand this. When one service gets affected, okay, it might even affect the invoker services, and ripple effect will happen for many microservices. So this could be a very bad situation for the projects. So basically it should not happen. Okay, and you need to understand one second problem. Okay, I think somehow with human nature also you can try to relate with this. Okay, just imagine if there is a student with lot of pressure. Okay, somebody maybe during academic or even in the real life, working people, like let's say even people in 30s 40s, sometimes living in lot of tension and worry. So this is kind of a stress itself, right? One service trying to talk to so many, not able to get it. There is waiting time, memory is running high. So this is kind of stress situation itself. Just imagine if this is a condition of a human being, very much stressful, problems are there, not able to manage things properly. And guys, try to relate with it. If in case on this person, other people are putting more requests, okay, already this guy is under pressure and you are giving more tasks to that. Okay, process my request also, process my request also, process my request also. Now what is going to happen? This person is going to break down, right? I mean, somebody is already under tension and you're giving more load, more load, more load to that person. So a point will come, this guy will completely break down and might even have health problems and other things. So similar situation, when you relate it to microservice, if one of the service is not performing well and you are adding more load to it, there is a very high chance this service will never recover. It will definitely crash or shut down. Think about it for a moment. If the service is already performing bad and you're adding more requests, it will further get more slow, and definitely it might lead to all threads are gone, memory becoming full, CPUs running high, and the service is going to maybe just get stopped. So this is the second major problem. Okay, so first problem is when one service is slow, the remaining system will also become slow. That's the first problem. Okay, what is the second problem? Okay, when one service is performing bad and you keep assigning more work to the same service, okay, then it will not be able to recover quickly and can lead to maybe service termination. Means you're not giving the chance to this service to recover from that painful situation. So then some solution can be implemented for this, and that is the concept of circuit breaker. So what is the problem here? First understand, in microservice world, many microservices can talk to each other. Now, it is possible when one service is doing a lot of things, it might slow down, it might get into performance problems, and all the invoker services will also be impacted because of that. That is the problem number one, because they are also waiting, so they also get affected. That is problem number one. Problem number two, if it is already under load and you are giving more API calls, there is a very high chance that service cannot recover back to a normal state, and it will lead to maybe crashing situation as well. So these are the two major problems when services are overloaded into our system. Okay, so guys, are we clear with this? Main problem is clear, right? Simple. And since we are in a software world, all these things will keep happening. Okay, now let's discuss solution. So solution is circuit breaker, guys. Okay, chalo, let's talk about the solution here. The solution for this situation comes with circuit breaker. The name itself, circuit, you try to imagine like electrical circuit. In your home, there is a wired connection, right? So when you put the button on, electricity passes from that switch to the, let's say, bulb or tube light, and the light grows. So then we say circuit is complete. So then electricity is passing. So similar kind of concept is what is this circuit also. If I have a closed connection so that electricity can pass through that. Okay. And then there is a concept of circuit breaker. So what exactly this circuit breaker, let's try to imagine. Okay. So let's assume this is service 1 and this is service 2. So earlier, everything is going to be fine. Whenever a request comes to this place, if this guy wants to talk to this guy, then it makes a API call. Let's say using REST client, you are making the API call, and then this guy does the rest of the processing and then responds back with whatever success, failure scenarios. Okay. Now the thing is, just imagine if this service is now getting into problems. For example, this situation. So let's say this service is now getting into problems. So what exactly is going to happen? This service should identify that the destination service is having a problem. So approach is going to be like this. Step number 1, how the circuit breaker mechanism works. Step number 1, let's call this as service 1, S1 and S2. Let's give it name S1 and S2. Let's write down, okay, what steps are going to happen. Step number 1, S1 is calling S2 regularly. Step number 2, S2 starts with low performance or no proper responses, nothing but it's under problem right now. Okay, so S2 is struggling with problems. Next, step number 3, S1 should identify that S2 is not behaving properly. Okay, so somehow this guy who is calling will identify, oh, there is a problem with that service. Okay, it will identify not behaving properly, nothing but there is a problem with it. How to do that? We will look at the code part also. But there is a problem with S2. S1 should identify that. Okay, now this is interesting, guys. As soon as S1 realizes, okay, there is a problem with this guy, what happens is S1 stops calling this service. API calls will not happen. Okay, rather S1 will assume that it is already a failure. We have already done the coding, right? Success handling, failure handling. So S1 will assume that it is already a failure. Because anyways, after you call, it is getting into failure only. So why to unnecessary call and then get failure? S1 will directly assume, okay, maybe we might have called it and now we got failure directly. So without making this API call, S1 will assume that it is failure and then it will process it like a failure in the S1 system. So because of that, S1 will not be impacted. It will not wait for this much of response time. And at the same time, this service will not get more API request calls. It will give more time for this guy to recover. So this is the solution. So what's the solution? First step, S1 is calling S2. Next, destination service S2 starts performing low or not giving the proper responses. S1 identifies that there is a problem with the other service. After that, what S1 does? S1 stops calling destination service S2. Okay, rather, we should continue here only. Rather, S1 assumes that destination service is not available and directly assumes failure. Okay, and in S1 logic, failure handling will be triggered. This is what is the first part. Now, what is the advantage of this? Advantage of this is basically about two problems will be solved here. What is that? First one, S1 is not waiting on S2, so S1 will not be affected. S1 will not slow down. Okay. Second solution is S1 is not adding more load on S2, so S2 gets time to recover. What does it mean to recover? Means since more load is not coming, the CPU, threads, and waiting time, everything will become finished, and this system will start becoming available back, maybe 50% RAM and 50% CPU. So once the current work is completed, it becomes back for receiving new request also. So that is what both the two problems can be solved just with this simple approach. Okay, means you are going to call and then identify a failure. Then why do you even call it? Don't call the other party. Directly assume a failure at your side and continue processing accordingly. Okay, this is one part of it. Guys, is this clear? Is this first part clear? Okay, simple as electric wire is there. Understand circuit terminology now. There is an electric wire, switch versus tube light. You realize there is a problem in the tube light. What you do is you break the circuit, maybe cut the wire. So if the wire is cut, your current will not flow. That concept is actually applicable here. Okay, let's assume this is a wire. So if there is a problem here, you cut that wire so that your API call is not going to happen. You will not be doing. And that basically is circuit breaker. Okay, that basically is circuit breaker. So circuit is broken, gone. Okay, but now comes the point. The circuit should fix also. Otherwise, every request of the system will always be a failure itself, right? So now, how do system overcome this? So there are further steps for that also. It's not like we should always assume Kit is gone and you should process like failure. No, we are giving time to this destination service to improve. That is what we are doing. So now comes the second part. So till the first part, we assume that it has failed. Now comes the second part of circuit breaker mechanism. Circuit breaker, you break the circuit. But now comes the second part, how to recover from this. Okay. Now it is going to be something like this, guys. If once this circuit is broken, now you can do the configuration that for how long this service should not call this service. It's a configurable value now. Maybe you can say for 60 seconds or 2 minutes or 3 minutes or 5 minutes. Now you will do this in programming. You will define that once the circuit is broken, for the next 60 seconds or 2 minutes, you assume that destination is not working, consider failure, and then work with it. Now it depends upon your project, what number you want to choose. Circuit breaker is giving that option to the development team. You decide what configuration you want. So what is going to happen? Okay, first step is S1 will stop calling S2 because of circuit breaker logic. Okay, step number 2, S1 will assume failure for configured amount of time. Let's say, for example, 2 minutes. So all the request which is trying to go to S2, so all of them will be by default assumed as failure for 2 minutes duration. So this is not like forever, and it is configurable. You define, do you want to do it only for 10 seconds? You can configure it like that also. 30 seconds, it's up to you. Depends, right? Because even 2 minutes ke liye everything is a failure. So that could also be a challenge. So you decide how you want to do it. But now that will be the second thing. S1 will assume failure, okay, for configured amount of time for 2 minutes. Once the 2 minute is completed, so all the requests which comes in this 2 minutes, they will be considered as failure request. Next, as soon as this 2 minutes happen, S1 is going to make a call to S2 again. S1 is going to make a call to S2 again to check whether S2 is up or not properly. That is going to be next step. After 2 minutes, S1 will call S2 to check if S2 is working properly. Okay. Now, there could be two possibilities. If S1 is working properly, S2 is working properly, then S1 will stop doing this drama and start making again direct API calls. Okay, so now there are two possibilities. It will check whether S2 is working possibility. Now, possibility number one is S2 is okay. Possibility two, so we can say 4.1 and 4.2, S2 is still having problem. So first situation was you're calling, then you realize the service is not performing good. So all of a sudden you stop calling this and you start assuming failure. We discuss this first part. But now for how long? Okay, configurable value. For 2 minutes, we will not call this service. We will assume everything is a failure for 2 minutes. After 2 minutes, S1 will again make a call to S2 and then identify, okay, what is the situation of S2 now? Two possibilities exist. Either S2 is good or S2 is still having problem. Accordingly, next steps will be decided. If S2 is working properly, okay, then automatically S1 will start calling S2 regularly for all API calls. So everything will be again back to normal. But if S2 is still having a problem, then S1 will again default assume failure and stop calling S2 for another 2 minutes time. Okay, it will again wait for this much time. So that is how the step-by-step mechanism is going to be. So this is a recovery process. So first, guys, let's understand. First, you call the API. If then you realize that there is a problem, as soon as you realize a problem, you stop calling the API. Rather, you assume the problem. Okay, by default, you assume it's a problem itself. So you are saving the network congestion also, and you are making sure S1 is also not getting into a bad state. Plus, you are giving time to S2 to recover. A lot of benefits. Next, what? You cannot like infinitely assume that it is a failure, because the work of the project is to work, right? So this is an intelligent mechanism, kind of a safety in the system. So when you are stopping to call S2, let's say you did not call S2 and you are assuming a failure, you can define for 2 minutes we are going to do that. Once we are done with this 2 minutes, okay, after that we will check whether S2 is working. If S2 is working, we will start calling S2 regularly. If S2 is not working, we will again get into the state where we assume failure and then we don't call them anymore. Okay, and this continuously happens. In services itself will keep checking the health of each other, and if it is in problems, they will stop calling. If everything is okay, it will resume back. So human intervention is not required. So we can build this kind of a mechanism which tries to call, stops, assumes failures, checks again without any human being. Services are intelligently able to connect using the concept of circuit breaker. Okay, using the concept of circuit breaker. Now we need to check it programmatically. So guys, understood? The base concept is pretty straightforward. Are we clear with this, guys? Circuit breaker base concept. Team, are we clear with this? So this is a technical topic, very common with microservices. So include this into your resume also. So include this word circuit breaker and say we implemented circuit breaker in our project. When they ask, okay, what was the problem? How did circuit breaker solve it? So then you have to do all this discussion. Okay. Now let's look at it programmatically. Let's look at it programmatically, how we can achieve this. So they have just given some libraries. So there is a library in Spring Boot or in Java. They call it as Resilience 4J. So using Resilience 4J, we can implement circuit breaker in our Spring Boot 3.x. So some POM dependency will be there. So regular Spring Boot stuff basically, right? POM dependency, some property file, and using this, the behavior can automatically be achieved also. Okay. Now you need to understand another concept with regards to circuit breaker. The way for payments, we have our status management. Status tells about payment, right? Circuit breaker is also going to have some statuses. Circuit breaker is also going to have some statuses. For example, closed status. Next, open status. Next, half open status. So the way we have created, initiated, pending, success, failure, every status tells us something. Like that, circuit breaker is also having three statuses: closed, open, half open. Okay. So what is a closed state? Now, same thing which we explained theoretically. Now they have some technical names. That is what it is. So what is a closed state? So the step number one, where service is directly calling service 2, that is a closed state. Closed state is like a kind of wire. Wire is properly closed. Okay, so when the wire is closed, we say it is a closed state. Let's say you have there is a break in wire, you have put in a tape, so electric current can pass. So that is a closed state. So when the circuit is in closed state, S1 calls S2 regularly. That is what is going to happen. Okay. Now open state. Open state is what? S1 realizes that S2 is not working properly. It breaks the circuit and assumes failure. That step is open state. S1 stops calling S2. It breaks the circuit and assumes failure. That state is called as open state. Circuit breaker states: closed state when you are actually calling, open state where basically you are not going to call. And third is half open. What is half open? Okay, we said, right, after 2 minutes, service 1 is going to check whether this is working or not. So that state is called as half open state. So where service 1 checks if S2 is working up or not. That is half open state. So basically, circuit breaker will have three states: closed, open, and then half open. So when it is in closed, try to relate it with electrical circuit. If the wire is closed, means current is passing. If the wire is broken, means current is not going to pass. And half open means conditional end. So you will temporarily put it together to see whether everything is okay. If there is a problem, you will again open it. So if everything is okay, you will move it back into the closed state. You will patch it with a tape. Current will start flowing through. Again, if it gets into problem, it will move back into open. So like that, try to relate with electric circuit. These status names will become clear for you. So in the beginning, I was also like, come on, they are calling it closed, but it isn't working. No, you have to relate with electric wire. So closed electric wire means current can pass, means everything is okay. Open means current cannot pass. So that is what is circuit terminology that they are utilizing here. Okay, now let's look at it programmatically. We are saying to implement this in the system, we have a library called as resilience4j. So we need to add it, and it internally uses some concepts of aspect oriented programming also. So we need to even work with AOP related some concept. So some jar of this AOP is required. And while circuit breaker is doing all these actions, if you want to monitor it, so today while we are doing testing, so we are going to monitor the changes. For monitoring the changes, Spring Boot has a concept of actuators. Okay, so actuator is for health monitoring. We will be using actuator today to check how the circuit breaker is behaving. So like that, actuator will be utilized. AOP is aspect oriented programming. We know this already. Before and after your method, some additional logic can be executed using AOP. So we will need some aspect oriented programming concept. Next, we will need some resilience4j, which gives the circuit breaker capacity. So three kind of jar dependencies are required. Okay, so be comfortable with these names. Aspect oriented programming means when you're calling your destination method, before that and after that, additional logic should run. So that is aspect oriented programming. So circuit breaker is going to use that. You will check it practically how it is applicable. Actuator means, okay, health monitoring. Nothing but when the circuit breaker is in multiple states like closed, open, and checking the health of these system calls, we want to do some debugging. We want to see currently, is it in open state? Is it in closed state? Is it in half open state? So for doing that kind of monitoring, we will be using actuator. So Spring Boot has given a new dependency called as actuator, using which we can monitor the state of the system. Okay, so we will be working with actuator. AOP is before after. Resilience4j is where the core circuit breaker logic is available. Okay, so first of all, we will try to do this scenario. Let's bring the two systems up. We have system 1 and we have system 2, and we are going to make an API call. Our system 1 is processing service. Our system 2 is Stripe provider service. Okay, so what scenario we will do is we will implement circuit breaker and all the logic here, because this service is going to call to the destination, and then we will experiment with this piece. Okay, now another question that we need to answer: how can this service realize or recognize that this service is down? We said as a step number 1, okay, when this service realizes S2 is not behaving as expected. Okay, let's try to look that. We go back to our HTTP service engine of processing service. Okay, so if that destination service is not responding to you properly, okay, that means basically these two scenarios, either here or here. Yes, if they have responded properly, means it will belong into here and it will belong into here. So our assumption that Stripe provider is not working properly is if we get these two things. If we are getting this problem or this problem, then we will assume that Stripe provider is not performing in a good manner. So what is our assumption? How does processing service identify that Stripe provider is not performing good? Two things. Okay, if we get service unavailable or gateway timeout, or we get some exception in processing, then we can assume it's a failure. Now, important thing is, whatever we are getting here, important thing, the method where you are calling this external guy, if that method throws an exception, then we assume it is a problem. Circuit breaker logic will be like this. If you are making an external call on this, if this method throws an exception, then circuit breaker will identify something has gone wrong. If you don't throw an exception here, let's say even if you are getting this, you still return a value, circuit breaker mechanism will not be triggered. So please understand. What we will do is, let's understand it programmatically. While making this API call, we have created this HTTP service engine. In this one, we have written something called as make HTTP call. And here we call our business logic. Here we are calling our business logic. Okay. Now, how can this service identify that there is a problem here? Programmatically, the best that they have done is they start monitoring this method. And they say, if this method throws any exception, we will assume there was a problem connecting to this service. And guys, that is where you have to understand right from the beginning, this is the primary reason where we are throwing this exception, so that even circuit breaker can do its work properly. Whenever we don't know, we don't get a proper response, we throw the exception so that even circuit breaker monitors it. Okay, when you have thrown an exception, means destination is having certain problems. It is not able to respond to you properly. So circuit breaker can do some default behaviors. Okay, so that is what we have to understand. So how does processing service identify that Stripe provider is not performing good? Okay, the method in which you call Stripe provider, if that method throws exception, then processing service considers it as failure to call Stripe, considers it as Stripe provider is not working as expected. Okay, and then it will start doing whatever circuit breaking related logic. So this is important thing to understand. Okay, so what is it? When you are calling the method, if you throw exception here, then circuit breaker is going to check that exception, and then it will assume, oh, there are problems when calling, and then it will run the circuit breaker logic. Okay, let's look at it in code, and then everything we will be understanding it step by step programmatically. So by the end of the practical demonstration, full 100% clarity will come. Okay, now in order to do that, we have just arranged all this code in one single place. So here we go. Circuit breaker mechanism, all the dependencies and everything, I have just put it into one place so we can straight away apply it and use it. It's all like you can go to ChatGPT, you can read it on Google, arrange all these required dependencies one by one. If something is not working, then find another dependency. So it will be a time consuming process. So I have already done that work, arranged all the required things together. Okay, like we realized, so we will be implementing circuit breaker using this resilience 4J library. Next, actuator is for monitoring purpose. If we want to know what circuit breaker is doing internally, then we need actuator. Okay, and then AOP, nothing but, now circuit breaker should get additional behavior, we said, right? If when this method is throwing an exception, circuit breaker should do something. What does that mean? Before this method is called, after this method is called, circuit breaker or some aspect oriented programming logic should be executed. So then circuit breaker can check, oh, it has thrown exception, let me consider it as a failure. So we need some additionally aspect oriented programming behavior also. so that when we throw exception, circuit breaker can realize it and do certain actions. For that reason, third dependency is required. Okay. And if you remember, while working with Spring AI, okay, there is something called as bill of material dependency as well, right? So these kind of circuit breaker resilience 4J is available as part of Spring Cloud. Okay. So for ease of version maintenance, they introduced some BOM dependency for this Spring Cloud also. The way for Spring AI. So just be aware, for easy version maintenance, sometimes you will also find this kind of BOM configurations available in your pom.xml. It is bill of material configurations. Okay. And it basically means you don't need to write versions here. Okay. And Spring Cloud is a big project available in Spring system, let's say spring.io. Okay. If I go here, Spring Cloud, let's look at here. So Spring Cloud high level architecture, it's for microservice. So it provides a lot of other mechanisms also. In Spring Cloud, API gateways can be set up. Tomorrow we are going to discuss service registry that can also be set up in Spring Cloud itself. There are some other concepts in microservices like config server. So these commonly used services, okay, or commonly used features in microservice, they are all available as part of Spring Cloud dependency. So that is what the Spring Cloud comes in. I think somewhere we can, okay, just read it for a moment. Developing distributed systems. Distributed systems means where softwares and pieces are running on many machines. So developing distributed systems can be challenging. Complexity is moved from application layer to network layer, right? So here you can imagine there are network calls, so many things going to happen here. So that is where they are saying complexity has gone to that, and greater, okay, and demands greater interaction between services, like one service calling another service. Okay. Making your code cloud native means dealing with 12-factor issues such as external configuration, stateless, logging, and connecting to backend services. Nothing but now they are simply saying for working on this distributed system, these are some common configurations which might be required. And for that, they have provided Spring Cloud related. The Spring Cloud suite of project contains many of these services you need to make your application run on cloud. Nothing but when you're running it on AWS cloud, and many software services are there. So as part of Spring Cloud project, these guys have provided us way to work, okay, to implement all these features. So just be aware of that. So for example, I think here we can go to Spring Cloud project. Just imagine under Spring Cloud, just observe circuit breaker is one of the project. Okay. And there are so many other ways of other features which is also possible. You can work with Sleuth for distributed logging. You can use Fiend. You can work with Kubernetes, gateways. So many features are available. Okay. So they have bundled all of this under one name, Spring Cloud. So nothing but, let's say in your projects, you might have to explore and utilize any of these services. So just read this paragraph. I will paste this link here. So using the Spring Cloud project, we can add these kind of behaviors into our project. Distributed and versioned configuration, service registry and discovery. Tomorrow we are going to do this. Plus additional lot of other logics can be included as well. So Spring team, so they analyze microservices, which said key many software pieces can talk to each other. And then they identified what are the common use cases for these software services. And they created a separate project itself called as Spring Cloud project. And in that they added all those features. which microservices might need commonly. Okay, so circuit breaker is one of this requirement. Tomorrow we will be seeing another commonly used, which is service registry and discovery. Okay, so these are some commonly used things. Other features are also available depending upon your need. You can explore on that and then apply it in the project. I will just put this one here in chat. So now, since there are so many sub projects, you might need versions for all this, right? So every Spring related project is a new code having some version. So in order to simplify that versioning, they have introduced a BOM kind of configuration for all Spring Cloud dependencies. So you don't have to specially write versions here. You can do it via this way. A lot of new things we are learning, right? AOP, Actuator, configurations, Spring Cloud. For microservice based project, some additional features might be required. Spring team has bundled them in a Spring Cloud based project. And for ease of versioning, BOM dependency, bill of material dependency is available. So that's what we can gain from all these conversation. Okay, guys, are we clear with this? And don't go, guys, point is, don't get overwhelmed with all of these things which are happening in the industry, because things will always keep changing. New things will always be there, and you go to some other framework, there you will find new things again. So point is, new and new things will always keep coming. As a developer, your mindset should be, let me explore and figure out what these things are. You cannot be like a student, I want to 100% learn everything. It's never going to happen. The knowledge is basically unlimited. Everything that you learn, there will be what more, what more, what more. And now plus AI is there, this is there, other programming is there, so many more frameworks are there. So basically knowledge is unlimited. So whatever you need for your project, get that knowledge and keep incrementally growing. That's how experience grows basically, right? So don't get into this, oh, I should know everything, and if I'm not aware, then what is going to happen? So don't get into that panic situation. Step by step, based upon the need of your projects, you have to learn, upgrade, and move it in that particular direction. Okay? Whatever common things are there for every framework, that you have to spend time in learning. Whichever you are learning, the base things you should always be clear, and many more new things will be there. One by one, when need comes, you can keep upgrading that area. Okay. So, but yes, don't try to master, like I want to learn everything. It's basically not possible, because whatever you learn, new things will be coming, because in IT constantly now, okay, Spring team is every day doing new feature development. So those things do not even exist in the framework right now. Maybe after 3 months, no new features will come. So how much you can actually catch up, right? So it's always a never ending process. So get mindset right. Incrementally, we will keep learning based upon the need and your interest to grow in that direction. Okay, don't try to do everything, because it's too much. It's way too much. But yeah, so what are we learning here? Circuit breaker mechanism basically says, okay, don't load services in the system. When one service is performing bad, you should not add more pressure on that service. Rather, you break the circuit, assume it a failure, and just continue like that. After some time, you check whether the service is up or not. All this logic is implemented already. So we don't have to write all that logic. It's already implemented. We just need to add jar, use some basic annotations, configurations, and we will be able to get this capability. Okay. Next, we can monitor. Next, circuit breaker needs this additional AOP mechanism to read our methods, to check the exceptions from there. So we will need that. And here we realized circuit breaker is given as part of cloud project of Spring, which are nothing but some set of tools to work in a microservice based service communications. Okay, fine. So this is what is available here. So we will be adding this. First, let's just start the services. Okay, we will first run Stripe provider, right click, run as. Let's make a successful API call first. and then we will make any changes in the code. Okay, so Stripe provider is working. Processing service we activate. This is about to start. Okay, 8082. This is also starting. Fine. Step 1 completed. Next, let's go to Postman and call one of the endpoint, processing service endpoint, localhost 8082. So processing service is running here. I'm trying to create a new payment. Okay, so that worked end to end. Next, let's try to initiate the payment. So with initiate, we will first call processing service, and then processing service will call Stripe provider. Then Stripe provider is going to call Stripe, and then journey is going to be back. Okay, everything is working. Current system is doing good. Fine. Step 1 we verified. Okay, bring both services up and test one round of create payment and initiate payment. Okay. Second, start making changes in processing service to implement circuit breaker. Okay. Now let's start doing those things. First, we need to go to pom.xml of processing service. These 3 dependencies are required. So we will take these 3 tags. Be careful when you are applying these configurations. Under dependencies, after our AWS secret manager, we are putting this. Okay. It needs some version for this one. So that clarity is missing. So we will be using the corresponding compatible version to Spring Boot 3.x. So after this dependencies tag, we will put this versioning. Just see that compilation error is gone. And yes, it is able to resolve itself. Okay, that's it. So these dependencies are added under dependencies subtag, and parallel to dependencies, we have dependency management where we are putting this one. So be careful. Don't put this under this one. No, it is a separate which is parallel to this one. Okay. So let me simplify your understanding. I will give you this. So it will be like this here. So this is the tag. Here you will have more other dependencies, whatever, and then you need to use it like this. So it is parallel. So this I'm just putting for your reference to understand positioning. Okay, fine. So 2 changes are done. Next, whenever we make changes to pom.xml, better to clean and restart it. So right click, run as, build, clean package. If it needs any property file, it should tell us right now. Okay. Otherwise, it might take some default values. Let's check it out. What happens? We know Spring auto configuration works, right? Okay. Okay, no problem. So we added jars. It might have started beans also, but it is not expecting mandatory some property files. It might have done some default assumptions. That's okay. Let's start the Spring Boot application. Right click, run as Spring Boot app. Go. Okay, it is up and running. 8082 is up and running. Very good. Now next we go. These 2 changes are done. Okay, fine. After that, we have to work with some annotations. Just look at it. There is an annotation called as @circuit breaker. We need to put this annotation on top of the method where you will call external system, HTTP service engine. Let's say here we are calling it. So whichever method we are going to make this external call, on that method we need to use this annotation. Okay, so let's try to put that @circuit breaker, Control Shift O. Just see it is imported because the jar dependencies are already added. We can check it. Circuit breaker resilience 4J. It is imported from that library. Okay, fine. Next, it has something called as fallback method. What is that? We will understand. Okay. We said, right, you have to assume that it is a failure already. So where will that logic be implemented? How do you assume it as a failure? They have used a fallback method mechanism for that. How exactly it works, we will look at that. Let's save the change first. Okay. So you just need to use @circuit breaker annotation on top of your method where you are making that call to external service. And what is this name? We will understand that. Fallback method is, let's say when you have called that service and now there is a problem, you need to default assume it as a failure. So where will be that logic for default failure assumption? We will write it under this fallback process payment. So we will be introducing this new method called as fallback process payment. Just see, fallback process payment. Whatever is the method name, you need to actually create a method with that and write your business logic. So in the same class, put this business logic. Okay. That's it. Okay, just imagine what is going to happen. Just imagine. When your code throws this kind of an exception, or when you get this exception, you are again throwing that exception, right? So in both the cases, we are just simply throwing processing exception that unable to connect to Stripe. So what does this mean? Okay, when this kind of problem happens, we are only throwing exception. So here, when the fallback is happening, we will continue to do the same thing. So we are not going to do anything else. We will continue that. Okay, the way that service was not responding. So you are not changing your business logic. You are only implementing your entire existing logic, which we discussed from all the right from the beginning. Okay, in HTTP service engine, we need to handle scenarios. If you get a valid success, valid failure, you need to return it back. So that is correct. Next, if you don't get a response, you should throw an exception. Now, what is going to happen is when we throw this exception, it will not go to controller advice. It will first go to circuit breaker mechanism. And in that circuit breaker, we are saying you need to call this method, and whatever logic you write here, that logic is going to take effect. If here you don't throw exception, you return a value, then your control will go back to payment service IMPL. Okay. However, if you throw an exception here, then it will go to Stripe provider service. Sorry, that global exception handler. Okay, don't worry. We will look at it once again. This is really amazing. Okay, our current code works how? Let's try to understand it with a diagram. Current code works in this manner. We created this, let's say, our invoking service. Even in revision topics, people have summarized this thing, right? Payment service IMPL is where you will call, okay, like functionality is running, and you will call HTTP service engine. You expect a valid response, either a success or failed, but you expect a valid response. That is what is the first part. Now, second part, HTTP service engine. This is really interesting. Put very strong attention. Here you are doing make HTTP call. Now, what is the current mechanism? let's say you get any kind of exception or no response. We said for no response case, if you don't get a proper response, what we do is we throw exception. Else we return response to payment service IMPL. So this is our business logic, and we want to keep it like this only, so it doesn't change. But how the current flow works? Current flow, when you throw this exception, this flow definitely breaks. So let's say you call this, then this runs, and you get a response here. So if you are returning a response, then this flow works. Otherwise, in the system, we have something called as controller advice. We have something called as controller advice. And as part of this controller advice, this exception is caught there. Current flow is like this, right? And then whatever you return here, accordingly, behavior will be. That is what is our current flow. Okay. Now, what we are doing is we are bringing some change to this flow with circuit breaker mechanism. Guys, technically it is very interesting, so please put an attention. What we are doing, we are putting another fallback method here. In the same class, we are adding one more method, fallback method. Okay. What is going to be our business logic now? In this fallback method, we are saying, okay, here we have added another annotation @ circuit breaker. Here we have added another annotation @ circuit breaker. So let's look at the full flow. So this guy calls this method. So invoker calls this method. Here this method is executing. If it returns a proper response, no problem. Response goes here, runs the remaining logic. That stays as it is. Success processing, no change. It works as it is. Okay. Whenever destination is not working properly, let's say here is type provider. If that is not working properly, our make HTTP call is going to throw an exception. But this exception will not go to controller advice because circuit breaker is capturing it now. It's like a aspect oriented programming. Before and after this method call, circuit breaker has taken an effect because of this annotation @ circuit breaker. And now what you're saying, whenever this method throws an exception, okay, you call, we are guiding the circuit breaker. We are guiding the circuit breaker. Whenever this method throws an exception, you call this fallback method. So circuit breaker is going to look, okay, so I need to find and call this method whenever exception is thrown. And that is where it will find this in the current class. And now it's up to you what logic you want to write. Now please understand, our code is going to go something like this. When this exception is caught, circuit breaker is going to catch it. And in the new flow, that exception handling circuit breaker is going to call this method. So this will not happen. So the basic nature of Spring Boot of error handling gets a bit tweaked here because circuit breaker is doing a different mechanism here. So when you throw an exception, first circuit breaker catches it. In the circuit breaker, we are saying call this method. So circuit breaker is going to call this method. Now it depends what business logic you want to handle here. So if you don't get any response, what is your business logic? Okay, so we said whenever we don't get response, we want to throw an exception so that accordingly proper error code error message can go. So then we need to write that business logic. If you don't throw it, what will happen? Whatever you're returning from here, that will again go back in the success flow, and then now this logic is going to break. So you need to be very careful. If you return a value from this, control will go back to this place even for no response case. and not sure whether you have handled that here, it might break into different angle. So you need to really be careful with this one. So now two possibilities. In the fallback method, you can either return a successful value, okay, return success, or throw exception. It's up to you, right? So how do you want to do it? It's up to you. But now the thing is, we will keep our logic consistent, that we will continue to throw exception. So because we have not handled no response scenarios here, it only expects valid. So we will continue to whatever existing logic was there, that will continue as it is. When we throw this exception, this exception will be further. Come on, man, these lines are crazy. Ek second, yeah. So these lines are going crazy. Okay, so first we will do this. Okay, fine. Now next we will go here. We will say when we throw this exception, exception goes here, 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 and here. Chalo. So finally we are able to take the exception to the destination place. And now the remaining flow is going to continue as it is. Okay. So this is a tweak. Please understand, while you debug, you need to have this understanding of the flow. So because we have wrapped this inside circuit breaker, whenever we throw an exception, it does not directly go here. Rather, circuit breaker is going to catch it, and we are telling to the circuit breaker, call this method. Now, what do you write the business logic here? That is important. If you return value, it will behave like success because you have done the handling. And if you throw an exception, then it will further reach out to the Spring related mechanism. Then the remaining part of the flow will happen. So we want the flow to be like this because our service layer only expects valid success or failure. No response is not handled at the service layer. So we are throwing exception. That is what we come here, and fallback is going to take an effect here. Okay, fine. So circuit breaker will always do this. Whenever your method throws an exception, circuit breaker will catch it and it will call fallback, and then this logic is going to execute. Now it's up to you what you want to do. We are keeping it consistent here so that we continue to raise that, hey, we did not connect with Stripe provider because it's a no response scenario itself. Okay, fine, very interesting. Now, second thing you need to understand. Okay, guys, did you get this? This flow is important. It will help you to code properly. And actually debugging may your actual brain will be required. Otherwise, it will become very crazy. Okay, fine. Now, second part you need to understand here. Everybody, please focus. We said two values in circuit breaker. So we understood this method, and we understood, okay, oh, this guy is acting like a wrapper on this call. Okay, fine. But it expects something else. Okay, this is nothing but some name of the configuration for circuit breaker. So we are supposed to create a configuration in the property file with this naming. Okay, now we took some example in the beginning today, that at least one example we took, 2 minutes. You need to be in this open state for 2 minutes before you call another API, right? So not just this 2 minutes, additional lot of other configurations are available. Some actuator configurations we need to enable so that we can monitor the circuit breaker. So multiple property files are required. Okay. Now I have arranged all those property changes here, and just observe. For enabling actuator, we need to use something like this, kind of monitoring some parameters. And for adding circuit breaker, we are using something like this parameter. Okay, we will be understanding these parameters at high level. So, but one by one, practically we will do it and we will understand. Right now, let's just put these configurations in our property file. So we go to local of Stripe provider service. Since we are running it in local, so we modify it here. You know that same changes you would have to apply it in environment specific property files also. Otherwise, there will be issue. So actuator we added, kind of monitoring will come here, and circuit breaker related these kind of property configurations. Okay, circuit breaker configurations also added. I'm saving the changes. Okay, we know when this happens, right? So we are giving our own values. So Spring is basically reading, hey, these guys have done some configuration, so we should not use our default configuration. Let's use these kind of values. Okay, and then it is trying to read all our values and set the values properly to the circuit breaker system. Okay, now whatever these names are okay. It's depending upon the field names what they have defined. Resilience 4j dot circuit breaker, and just observe this is important. The name that you are defining here, this name is what we have configured here. So we are saying all the configurations which we have defined in this property. So just observe, this is the main name and it has multiple sub properties, right? So these are your actual properties, but they're all linked with this one, payment processing service. So whatever is the main configuration name that we have applied in this place. Okay, so what we are telling here to the circuit breaker, that hey circuit breaker, read from the property file all the configurations of circuit breaker with this name and accordingly run the circuit breaker logic for us. Okay, what is that circuit breaker logic? One by one we will understand, but let's see. These are the changes. Okay, so this configuration is coming from property file and we are asking circuit breaker to use those configurations in order to give us the circuit breaking effect. And whenever you feel any problem, exception has come in, you need to call this fallback handler where we have written our business logic, okay, how to do the further handling. Okay, so this is what we have done. In order to test these things, we will be using breakpoint mode. So let's do that. Okay, so first we will stop the processing service. Debugger mode mein we can put breakpoints and test it properly. So let's start this in a debug mode. Right click, debug as Spring Boot application. Okay, chalo. Okay, 8082. We go here. Let's remove everything. All the breakpoints are removed. Okay, first let's try a straightforward scenario. Okay, there is one more thing. Because we have added the configuration, you can open the health monitoring here, actuator monitoring here. Just check it out. This endpoint, as soon as you add actuator, you can find this kind of an endpoint. Okay, so in the form of a JSON, you are now getting internal state of your circuit breaker component. So since we have added all our circuit breaker mechanism, on your whichever port your service is running, just with this endpoint actuator.health, you will be able to monitor the health of this circuit breaker. Okay, what are all these parameters? We are going to check on that, not a problem. But just observe here, we said sometime earlier today itself, circuit breaker deals with something called a state, closed state. What is the meaning of closed state? Means service 1 can call service 2. That is closed state. Service 1 can call service 2. That is closed state scenario. So that is the step number 1, right? Every time service will actually call it. And then if the problem starts coming, then circuit breaker behavior will become effective. Okay, fine. So currently we are at a beginner state. Everything is just set to 0. And now we are starting with our testing. Okay, chalo, let's check it out. It's very interesting, guys. Put focus. We will put some breakpoints here. Okay, HTTP service call. Let's say we are calling this from where? payment IMPL service. Let's put one breakpoint before this method call. Next, let's put one breakpoint in this method call. Next, let's put up a breakpoint once we get the success response. Let's put up a breakpoint once we get 4xx, 5xx problem. And let's put up a breakpoint once we get this kind of an exception. Next, let's put up a breakpoint once we get fallback process. We need to check everything, right? So fallback process. And let's put up a breakpoint once we get global exception handler, this call. So every possibility we have taken except one, payment service IMPL. Here, after this call also there could be one possibility, so that we missed out. So we have now covered everything. Whatever things can happen, we have added checkpoints everywhere. Now let's do a success scenario first. Guys, testing of this circuit breaker is very interesting. You need to be really focused, otherwise you will miss here and there. Okay, so chalo, let's focus on the first one. So first step is success call we will do. Okay, now let's focus on one parameter here. If you launch this circuit breaker, current state is closed and all of the numbers are 0 here. Okay, let's make our first success API call. So we go to initiate and let's check whether the breakpoint, okay, fine, everything is okay. Let's calls. Okay, you reach to this aspect. You're about to call the HTTP service resume. Okay, you are inside that method, make HTTP call. Fine, that is what you're supposed to do. Next, you will call the Stripe provider resume. Okay, all that drama happened. You were able to call Stripe provider called Stripe, got the URL, gave the response back. So success scenario, everything is happy. Now what do? You take this response, you return it back. Guys, AOP is triggered or not? Earlier, directly the response used to go. Now, if you are returning it, AOP mechanism is triggered here. This is all aspect-oriented programming is what is now AOP utils. Just observe. So because we use that annotation at the rate circuit breaker, now this API call, make HTTP call, is wrapped inside a AOP call now. Anyways, I'm doing a resume. And what do we notice? Even though AOP is there, it identified that there is no problem. Response came properly. And this guy is returning the response to the payment service IMPL and now continue with the remaining process. So now we are able to continue with the remaining process. Okay, the straightforward case, what are our observations? Success call. Okay, on success response, we got, okay, the response AOP was triggered. Okay, response from HTTP service engine was received by AOP and it called payment service. It continued, not called, it continued to payment service IMPL, and then rest of the flow continued. Okay, rest of the flow, that is fine. Here we go, it is returned back. Okay, fine. Now let's try failure scenario. Okay, but before we do that, let's go back here and try to refresh this page. Observe, buffered call is one, nothing but one call went through the system right now. Buffered call is one, means one call went to the system. Before trying the failure case, let's try a success case, but without a breakpoint. Okay, without a breakpoint, one more success scenario I'm just trying to call. Okay, everything went happy. Let's look at the stats, how much it changes this time. Observe. Okay, 2 calls happened. What is happening? Circuit breaker is measuring our process. Observe one interesting thing. It is also measuring slow calls also. The previous one, we added a lot of breakpoints and gradually we were playing with it. So it is even measuring that, oh, one of the call happened really fast and one call actually took a lot of time for processing as well. So kind of some internal monitoring is there by circuit breaker on our behavior of the system. Okay. Now, still note, everything we are saying closed only. Okay. Now, let's try one failure scenario. So we will try now fail case. How do you try a fail case? Bring down Stripe provider. We will stop Stripe provider and then we will see how the flow happens. Okay. So this flow was clear. So AOP was triggered, it took the response, it gave it, and it moved. Fine. Now failure case. Bring down Stripe provider. Bring down Stripe provider. Let's go here. You go to what? Stripe provider service, and we will be stopping this. Gone. Next. So we will have only processing service. Okay. Next. Let's enable the breakpoints. Check. So focus on these statistics now. 2 request calls we have made. Still, everything is in a closed state. Let's try to note down that observation. Before call, 2 request, both success. Now we trigger failure. Okay, let's do that. So we enabled the breakpoints. Let's go ahead. Let's call it back. Okay, what's happening? We are about to call make HTTP service. Okay, you call that. Control went to make HTTP service, where circuit breaker AOP mechanism is also now effective. We are about to call the destination service, but we have brought it down. So it is throwing exception. No problem. Everything is good. Next, in the previous scenario, when we throw this exception, direct controller advice was called before we write anything about circuit breaker, right? Stage 1, controller advice was called. Now we have a circuit breaker mechanism. Let's say when you throw this exception, where exactly you reach? Let's try to check that. Throw. Okay, what is happening? Circuit breaker has caught our exception, and we have told circuit breaker, okay, hey, whenever there is a failure, you need to call fallback method handling. So circuit breaker has called fallback method handling. Okay. Along with this, now let's refresh here what is happening. Observe. Circuit breaker is not checking. Okay, 3 calls happened. Out of that, 1 is failed. Earlier this count was 0, but now it is saying, okay, the total 3 calls happened. 1 is failed. Circuit breaker has tracked those details and now it has called our fallback method. Now we will do the rest of the logic, which is what? Throw an exception or return a value. If you return, it will give it back to payment service IMPL, which we have not handled for no response scenario. So we are throwing an exception so that remaining flow stays as it is. So we throw this exception. Just see, now global exception handler is triggered, which is receiving it, and this guy is going to return back the response, and which we are able to see here, unable to connect to Stripe provider. Very interesting. We will go back here and refresh this page once more. Okay, the numbers remain what we have seen. So this is what, let's try to make a note of this. So 3 requests done and 1 failed out of that. What is the state? State is still closed. What is the meaning of closed? Closed still means call the destination service. Okay. Now comes the point, okay, when will the circuit will actually open? Because entire thing about circuit breaker is, okay, when the destination service is down, you need to stop calling the destination. Okay. Now all this behavior will be controlled by parameters. Okay. So let's go. Now it's the time to understand the parameter related concept. We will go to local. Okay. Just see what are we saying. This parameter defines our behavior. Minimum number of calls 5. Nothing but till 5 counts are done, you don't try to do anything. You continue with your closed behavior. That is what we are doing with this circuit breaker right now. Minimum number of calls 5. We have made only 3 calls. That is where circuit breaker is relaxed right now. It's not doing anything because we control the behavior of circuit breaker. Okay, when it should open, when it should close, when it should go to half open state. These parameters are confirming that. Okay, so if we can put this into diagram in parallel, it will be more interesting and clear for us to understand. The current state of circuit breaker is open. The current state of circuit breaker is in open state. And it is here, okay, because it is waiting for 5 requests. Minimum number of calls 5. So currently it is only incrementing it. So it has made a total 3 requests. Okay, only that much. Now let's try the 4th request. Okay, let's try the 4th request. So we go here, everything is breakpoint enabled. We try the 4th request. Go here, call, guys, keep an eye. We are about to call make HTTP service, make HTTP call. We call that method make HTTP call. Service 2 is still down. We get an exception because service 2 is still down. This is the catch block. Service 2 is still down. You throw the exception. Circuit breaker has caught it. It is calling the fallback method. You go back here. You check the stats. Count was 3 and closed. Now you call it again. Count is 4 and closed. This is our state of the object. Currently, first let me resume this thread. It resumes back, goes to global exception handler, continues with the remaining flow. But what did we learn here? We learned the state is like this. Okay, let's try to rectify this. Just a second. Just a second. Okay, this is the object. Okay, this is the status on call number 4. It is observing that out of 4 calls, 2 calls have failed. It is observing. So now as per diagram, it is incrementing further. This 3 became 4. And still we have kept it here only in closed state because we are saying till the time 5 requests is happening, till the time 5 number of calls are done, minimum number of calls is 5. Don't do anything. Don't try to act smart. Be there in your closed state only because we want to give time. Because network may 1-2 fluctuations can just happen like that. It should not stop everything because of 1-2 fluctuations. So we are giving some time to API. At least wait for minimum 5 number of calls before circuit breaker you do any decision making. So we are controlling the behavior of circuit breaker, making it safe for our project. Otherwise, one network termination and it will assume, okay, now for 2 minutes, I don't want to call it. That's a blunder. Okay, one call might just fail here and there. So now we are controlling minimum number of calls as 5. Okay, so what are we going to do? Next call is going to be our 5th call. Let's try to check it out. Next call is going to be our fifth call. Okay, let's try to reproduce that. So call number 5. Breakpoint is hit. We are about to call HTTP, make HTTP call. This is call 5. You are calling that. Service is still down. You got an exception. You gave the exception to the controller, this guy, circuit breaker. Circuit breaker called your fallback. You called this, it went to global exception handler, and it has returned back. All this thing is okay. Now let's go back here and refresh this page to see what has happened. Behavior is changed. Observe, the behavior is changed. The circuit is in open state now. Let's capture this object to study it in more details in our comparison. This was previous. This is now. Okay. This is now. What can we learn? What can we learn here? As soon as 5 API calls happened, we controlled that behavior. Okay, 5 it should be. As soon as that 5 API call happened, circuit breaker took some effect. It measured out of the 5 calls, 3 calls were failed. It did a percentage comparison about failure rate. Okay, 3 out of 5 failure is 60% failure. If it would have been 4 out of 5 failure, means it is 80% failure. If 5 out of 5 call fails, it will become 100% failure. So what exactly happened? Let's try to break it down into bullet points. What can we learn here? Okay, when we attempted 5 calls, okay, then till 4th call, everything okay. Okay, but when 5th call happened, everything okay means it was only counting what is the failure and everything. Only tracking, incrementing was happening. But when 5th call happened, okay, it measured the failure rate. Observe here, the rate is considered as -1. Its default value, it did not measure anything. But when the 5th happened, then it measured this. Means, okay, 3 requests out of 5 failed. So it's 30% or 60%. It's 60% failure rate. Okay. Now, what have we done it? There is a second configuration which is available in the property file. Second configuration which is available in property file, which we are saying failure rate threshold should be 40%, minimum 40%. Now it's a configuration. So we have done a separate configuration which says that failure rate should be minimum, threshold is nothing but minimum, it should be 40%. That means when this calculation has happened, so we are telling if the calculated failure rate is greater than or equal to 40%, okay, then move to open state. This is the business logic. I'm not really sure whether this equal to is also coming. Ideally, I feel equal to should be there. Greater than 40 pe, so definitely it will happen. Equal to pe, I have not done that very precise testing whether equal to is considered. You check it out when you're doing the testing. You can try to produce a let's say 40% scenario, means 2 requests should fail out of 5, and then check whether it is moving into open state. If that happens, means equal to logic is applicable. Otherwise, yes, greater than. So whatever. But the point is, as soon as 5th call happened, it measured how much is the failure rate, and then we provided another configuration. If this failure rate is more than our configured value, then you need to move it into open state. What is open state? Open state means you don't call the next guy. Okay, we already know what is an open state. Let's first put this into diagram. Okay, sorry, earlier the status is closed. Earlier the status is closed. Closed means service 1 calls service 2, and we kept incrementing this. That is what is this. Earlier the status is closed. Closed means service 1 is calling service 2, and we kept incrementing this. Okay, we kept incrementing this till 5. Now, as soon as 5 happened, we now have a new status, which is open status. But how did it go into this open status? There is business logic for that. Okay, what is the business logic for that? In order to transition, two things are required. Minimum number of calls should be 5. Minimum number of calls should be 5. Then it starts measuring, and the second funda to measure is your failure rate should be more than this one. Now the second configuration is, what is the second configuration? The failure rate. The failure rate should be greater than or equal to you verify by your testing. I'm not sure about equal to. Generally it says equal to threshold. Could be there, but not sure. Test it out. But failure rate, if it is greater or whatever to your threshold value 40, then you will change from this state into this open state. Okay, what is the meaning of open state? Okay, service 1 doesn't call, or let's call it does not, to emphasize the meaning of not. You don't call, okay, service 2. You don't call it. You assume it to be a failure. You default assume failure and process accordingly. That is what is this open state. Okay. Now we are about to test the open state. Okay, we are about to test the open state, but let's do one thing now. This is the current state, right? I'm doing a refresh here. What happened? I just did a refresh. We were explaining, we were discussing the topic. We did not even try anything. It automatically moved to half open state. That means there is again some business logic circuit breaker is doing internally. What is that? Let's try to understand. Observe multiple things. It reset all the values. Everything is back to 0. State is changed into half open. Failure rate is also reset back to default. What happened? Okay, so third status is introduced. Okay, so third status is introduced, which is a half open state now. And in this half open state, behavior will be something different. We need to call the stripe and check it out again. So we will not test this half open right now. We will just try to understand. We did not do anything. How did open state come into half open state? Let's only focus on that part here. Okay, again, this is a configuration which we have defined in the property file. You go here. Now just observe. We told here wait duration in open state is 60 seconds. So we mentioned that in the open state, the wait duration is 60 seconds. Means if you are in an open state, you should only wait for 60 seconds. That's the time which we have configured. Second, we have given one more parameter saying automatic transition from open to half open enabled true. Means we are saying we will not do any additional thing. You itself, circuit breaker itself, should automatically transition. Observe. These two things has happened in our property configuration, we have configured it like this, that whenever circuit breaker is in open state, open means you are not making an external call, rather you are just waiting here. Whenever you are here, you wait only for 60 seconds. And after that, we said automatically after the 60 seconds, you itself change into half open. Okay. So that is what has happened right now. So if we are refreshing it, it is taking the behavior like this. Okay. But now, so let's try to draw some conclusion. This is really interesting. Okay. So, so we called 5 till 4th, everything is okay. It was only counting, but as soon as 5th happened, it calculated threshold and it moved there based upon this logic. Okay. Now we are in open state. Okay. We still need to test the behavior of open state. So this is to do. We have to do this. But before that, we have learned another thing. Okay. We configured these two values. Okay. We configured these two values. Because of that, what will happen? Because of above two values, circuit breaker, okay, waits for 60 seconds in open state and then automatically change to half open. The name itself is very clear, half open. Okay, the expectation from half open is to call service 2 and check if it's working. But we will go to that half open testing later. First, we need to really understand open state testing. Okay. Now, what we will do is we will try to test the open state. Currently, it's already in half open. So we will reset everything, start from beginning once again. Okay. How do you start from beginning? You just need to restart your Spring Boot application once, HTTP service engine. Please note, DevTool dependency is enabled. So whenever your Spring Boot application is going to restart, circuit breaker tracking is going to reset. Okay, please be aware of that. So if you're doing testing, every time this restarts, this count will always reset. Just see, right now it is in half open. As soon as it restarts, the count will be reset back till the beginning. It is back to closed. So a lot of times juniors get like, Arey, I'm testing, why the counts are not behaving? Arey, you are restarting because your DevTool dependency is working behind the screen. So be aware of that. So whenever your Spring Boot application restarts, the circuit breaker configurations are reset. Tracking will start from the beginning. Please be aware of that. Okay, please be aware. When your Spring Boot restarts, all circuit breaker tracking will reset to start from beginning. This is important. Okay, sometimes silly mistake, it might kill a lot of your time. So please be aware. Okay, now we want to test this scenario. We tested the first scenario, how it was working. So we tested this scenario. In closed state, we kept on making calls. We made some success, we made some fail, and then it was incrementing. Then we saw that up to 5, it did not do anything. After that, it calculated threshold, and then it moved to open. Till this time, we have done the testing. Okay, now in open state, we want to do some more testing. Okay, what are we going to do here? 60 seconds is very small window for getting some decent testing. So I will change this configuration that be in duration to wait in open state. Let's make it 120 seconds, 2 minutes, because 60 seconds we are explaining, and in that itself it might pass. Okay, so we will ask it to be, let's say, 2 minutes now instead of 1 minute, and we will try to do some testing accordingly. Okay, so everything is restarted back again. Go back here. Fine, 2 minutes. So just a suggestion for testing open state. Today, do this configuration with breakpoints, test it. Your brain will open up about how to think, how to do debugging, and play with these configurations. Your mental maturity will grow as a developer. Okay, for testing open state, we are changing circuit breaker wait time to 120 seconds. Okay, or open state wait time to 120 seconds. And now let's test it. Okay, here we are. We refresh it. In order to get it like this, I have installed some browser plugin. So by default, it might just come in one line. To view it like this, some browser plugin. So just go to Google, okay, what JSON prettifier plugin you can add to Google Chrome. You will get some option. Just accordingly do the setup. Okay, fine. Next, moving on. Let's try to test the failure scenario again. So we call this first call, about to make the API call. Okay, you are now calling it. You got exception number 1. Circuit breaker caught it, called the fallback method. You have thrown it to exception handler, and now you're returning the response. First call happened, first call failed. Go here. Yes, first call happened, first call failed. Very good. Second call. Second call. About to make a call. Inside make HTTP call. You called, exception came. This guy, circuit breaker, caught it, called the fallback method. This is second call. Now, global coming. Okay, we are here. So 2 calls we did. Okay, 2 calls we did. Both of the call failed. Now, we will skip the breakpoints. Call it 3 times. Same flow is going to happen. Third time. You come back here. You refresh it. Yes, 3 called, 3 failed. Status is closed. Everything is working as expected. Trying the 4th scenario with breakpoint, skipping the breakpoints. Okay, 4th scenario, failed. Come back here, refresh. Okay, so 4 called, 4 failed, status is closed. Here we are. Status is closed. Service 1 is calling service 2. Counter is 4. Now, when the 5th happens, then behavior takes in place. So we will enable the checkpoint breakpoints back again. This is how you keep using skip and not skip to test it properly as well, right? So that is where you will get more good control on debugging skills while you're playing around with circuit breaker. So enabled it back again. Let's try the 5th scenario. We go back here. You call. Breakpoint is hit. You are about to call, make HTTP call, right? So you're about to call that service. So your now 5th attempt is going on. You reach here. Now you will make a call here. It did not connect. It gave an exception. You're throwing an exception. Circuit breaker caught it, calling the fallback method. Okay, it come here, and now you're returning back. Okay, let's look at the stats. Before I do the refresh, let me copy this stat. This is the previous attempt. This is the previous attempt. Now we will refresh the page. Refresh. Observe. The behavior changed. Okay, it is in open state. 5 calls, failure rate 100. Okay, we already tested this. Now let's try a failure scenario. For 120 seconds, we are in open state. So we need to be fast. Within 120, situation should be different. Now we are in open state. How does it work? Call it. Just observe. We are about to call, make HTTP call. Resume. Observe. Circuit breaker did not call, make HTTP call. Circuit breaker straight away went to fallback method. It bypassed this completely. Breakpoint did not happen. Now that is power of circuit breaker. It skipped your method call completely. That is, service 1 does not call service 2. You assume a failure and you return it like a failure response. So you go back here. Now you refresh it once And what do we see? You are in open state and not permitted calls is 1. It is now tracking your not permitted call. Let's try it once more. It is very interesting. So you try to call. Circuit breaker is in open state. If it is in open, it will not even call this make HTTP call. Rather, it, okay, 2 minutes might have passed out. So if 2 minutes are passed out, it is going to then call back again. So those are the behaviors. We can test it once again. Okay, just see, it has moved into half open. So if 2 minutes are gone, it will again go back to half open, and then the drama is going to be there. Okay, so this time we will test this scenario with 3 minutes, so we get some more testing time also this time. Okay, but this is interesting. It bypassed make HTTP call. That was great. Programming did that for us. AOP concepts did that. So before you call the make HTTP, AOP came in picture, and it is checking already it is in an open state, means I am not supposed to call that method. I am supposed to directly call fallback method. That intelligent logic executed. We saw it only once. We want to test it again. This time I will be changing it into, okay, let this thing happen, not a problem. We will change it into, to test this behavior once more, we will change it into, let's say, 180 seconds. So then we can have 3 minutes to do this testing. Okay, save it. When you save, everything resets. Then you save, everything resets. You go back here, you refresh it back again. Okay, everything closed. Means service 1 calls service 2. Great behavior. Service 1 calls service 2. Regular behavior. Everything is in this manner. We will call only the first endpoint. First time we are calling. Breakpoint is hit. You are about to call make HTTP. Then you are inside make HTTP. Your call failed. Circuit breaker caught it. It called the fallback. You threw exception. It called global exception. It went here. Your entire tracking is incremented by 1. Yes, buffered call is 1, and you have failed call. Next, let's do the remaining 3. We will stop the breakpoint, skip the breakpoints. Attempt number 2, attempt number 3, attempt number 4. 3 times we tried. Let's go back here, refresh the page. Perfect. Attempt number 4 done. All the 4 are in this scenario. Failed. Currently still open. When we do the 5th, that is where magic is going to happen. This state is going to change into open state, and this threshold is going to be calculated. 100% failure will be there because you tried 5 and it will become 5. So with, okay, let me put a breakpoint once more so that you can get the behavior on the last time. We have 3 minutes, so we can do good amount of testing this time. Let's go back again, skipping the breakpoints. Enabling the breakpoints, trying it for the 5th time. Okay, you're about to call make HTTP call. When you resume, you actually call make HTTP. Then you fail, exception is coming. You inform to the circuit breaker that it is a problem. Circuit breaker calls this. Now you throw. Now global exception, everything is fine. Circuit breaker counted it 5, moved your status into open because failure rate is like this. Now you are in open state. Behavior is different. Open state means you are not supposed to call service 2. How does that happen? Let's check it out. So when you are about to call in an open state, you are about to call make HTTP, resuming, you don't call make HTTP. Circuit breaker saw it's in an open state. I should directly call the fallback. Means you already assume it to a failure, and then you resume, and rest of the flow is going to be the same. You go back here, you refresh this, and then you are saying, okay, not permitted call is 1. You do the same thing again. Okay, second call you're doing. You go back here, about to call. Okay, again it went back to the fallback. Resume. For 3 minutes, we will be here only. For 3 minutes, we will be here. Just see, not permitted calls are 2. Now, let's skip all the breakpoints. Let's skip all the breakpoints and try it once more. Okay, let's refresh the page. Just see, not permitted calls 3. Nothing but when you are in open state, every call that you make, 1, 2, 3, 4, 5. Just observe. When you are in open state, it was 3 earlier, now we did 5. Everything is not permitted call. Means in all the case, make HTTP call did not even happen. You bypassed it, fallback happened, and now it continues like this till the open state. Okay, guys, did you get it? It was very interesting. When I learned circuit breaker for the first time, I was like, "Arey, wow, what kind of great behavior these guys have done." Intelligent API calls. Your method is completely skipped when it is in a different state. So developer is calling the method and it does not even go also. Awesome. That was really interesting. Okay, now let's take some notes about it. Then we will test half open state, and that will be the last point of our today's discussion. Okay, fine. Let's continue. Let's take some notes here. Great observations. Okay, what happened in an open state? So in the open state, S1 does not call S2. Let me write it outside so we can get some pointers here. In open state, this is the open state. What is going to happen? S1 does not call S2. Okay. When service tries to call make HTTP call, okay, then circuit breaker checks that it's in open state and directly calls fallback method, and it will run that logic. So you default assume failure. That's what this is. You default assume a failure. That is what happens in an open state, and we have tested it practically right now. Open state behavior. Open state behavior is going to be like this. Next, for how long it will continue in open state? We know that already. Okay, based upon these two parameters. So currently we said 180. So after 3 minutes, it is going to go here. Okay, okay, you default assume failure. Now, based upon above two properties, it will automatically move to half open. Let's say in our example, now we changed it into 180 seconds, like 3 minutes, half open state. After 180 seconds, which is 3 minutes. Awesome. Okay, so we just have to wait for 3 minutes. And I think already we have waited for a long amount of time. Let's refresh it and see. Perfect. It's already in half open state. What do we learn from half open state? It has reset everything. Okay, I think we should add this point also. In open state, it comes this also, right? So when we keep calling in open state, it never makes it has not called the method. To forget, your REST client logic itself is not running. It is not even calling the service. Okay, it never makes call to S2. Okay, since REST client method make HTTP call itself is not invoked. Okay, fine. Now what happens is, so when you keep calling in open state, it only increments. Okay, so in open state, it will only increment not permitted calls count. Okay, but will not and will just call fallback handling. Okay, that is what is another observation here. And then you will wait for this much amount of time, and then you will go to half open. Now we need to understand half open conceptually as well as technically. What happens? Okay, so half open state is where we said two decisions will be happening. In half open state, two decisions will be happening. Okay, it will continue to be in half open till the time you have made a decision, okay, whether you want to go it in closed or whether you want to go it in open. So what is going to be the decision making? Let me write it here. From half open state, you will make this decision. Okay, you will make this decision, and this decision will lead whether you want to go to this place or whether you want to go to this place. So it's a basically circle. If you go back to open, again the same drama will happen. Everything will be not permitted, not permitted, not permitted. Then you will wait for 60 seconds, true, or again come here. Then again this check will be done. If it is still deciding it's not working, you go back here again. So it will be in this loop till the time this says success. If this guy is making success, it goes back to the closed state where you regularly call the other services till the time this condition is met again. So guys, it is a self-adjusting system. It keeps switching. It's kind of a toggle, on, off, and very intelligent. The machine is taking care of itself without we doing anything. We just need to set it up properly, observe it, test it, and it is supposed to work for us. So it will, everything happen automatically. Okay, so now let's understand the power of this open state and what is this condition which works here from half opens to go further. Okay, fine, let's check it out. So currently we are in half open state. Everything is reset. Failure rate is the reset. All these things are also reset, and it is now doing new calculations for us. Okay, what is that new calculation? Let's read it from the configuration file. Local. Okay, just see. Permitted number of calls in half open state means 2. That means now we are trying to try to understand what we are trying to do. If you are in open state, so you are not calling third party. Okay, you did that for 3 minutes. After that, we want to see whether third party is working or not. So if you want to see whether third party is working, you have to call third party. You have to call Stripe provider. So that is what you tell here. When you are in half open state, we want to call third party so that we check whether it is working or not. For doing that, we do like this. We say permitted number of calls in half open state means like this. You use this factor. Let me do some adjustments of boxes here. Okay. So in half open state, you will basically be doing like this. Permitted number of calls in half open state is 2. Means 2 calls you will actually be doing to S1 to S2. Based upon this factor, we will make 2 calls where S1 will actually call S2. So in half open state, S1 will call S2 the way it behaves in open, but only 2. Okay. So once you have done the 2, then after that 2, you will again check the failure threshold. Okay. So after 2 attempts, you will again check this failure threshold based upon your configuration here. So this condition becomes this one. Let me put it like this. This condition becomes this one. You will be checking it like this. So, but only for 2 requests. So as soon as you are in half open, your service 1 is going to call your service 2, but only 2 times. And as soon as these 2 calls are done, it will calculate out of these 2, how many were successful, how many were failed. Percentage will be derived for that. And based upon how much threshold percentage was calculated, it will compare it with the threshold. If this failure rate is still more than the threshold, it will move back into the open state, and this thing is going to happen. So is failure rate greater than equal to threshold? If the answer is yes, then you will go back here. If it is less, if it is less than the threshold, if it is less than threshold, okay, if it is more than threshold, so the behavior is going to be done like this. Okay, let's test it, then we will see. But what is the first thing that we are understanding about half open state? Half open. Half open means you want to check whether S2 is up. Basic aim of half open is to check whether S2 service is back up. So if you want to test it, means we need to call S2 service. Okay, but we will call it only for 2 times based upon number of permitted calls. So again, everything is configurable. You can change it 2 times based upon this thing. Okay, once you have done it 2 times, then you calculate failure threshold. Okay, and then you decide if failure threshold or failure rate, then you calculate what? Failure rate. Let's use the right words. Then you calculate failure rate. Okay, then check if failure rate is more than threshold. Okay, and if it is yes, if still failure is more, then move to open state where you know already the behavior. If failure rate is less, means it is working back again, right? If the failures are not happening, you're getting good count. So you say, oh, failure is less, means service 2 is working. And then you move back to closed state. Closed is nothing but S1 actually calls S2. So this is the understanding about half open state. This is how the behavior is going to go for half open state. 2 calls we will be doing. Then we will be measuring how much of that is success, how much that is failure. And then you will make a decision whether to go here or whether to go here. So first we will try this scenario. We will not bring Stripe provider up. We will keep it down. We will try this case. Both of the calls should fail. 100% failure we will reproduce, and then it should go back to open, and then we should come back here. And then we will try a success scenario to go back in closed, and that will be the full cycle of our journey. Okay, so let's do that. So currently we are in half open state. All the counters are reset. We can do here only 2 API calls. So let's go back here. Enable all the breakpoints. So it should not be skipped. Enabling all the breakpoints. Try the first call. Failure should come. Okay. Let's check it out. You are about to call make HTTP call. We are in half open state right now. Refresh. Refresh means like let the thread go. We called the method. So in the half open state, you will call the destination service. Okay, so we called, and now whatever happens, success or failure, it will track. So here also failure is happening. As soon as we throw the exception, that guy will realize, okay, so guys, failure, it incremented it, and now it called the fallback. The remaining logic is same. You go back here, you refresh this page once, it has started tracking. You made one call, and that one call is failed, and the state remains in half open. We said permitted number of calls is 2, so it will wait for trying one more time. Then it will do its action. So we go back here, and then we try to call it again. Okay, it goes back here. You're about to call make HTTP call. Okay. Yes, you are inside that method, means you are about to call it. Again, it failed. So second request also is failing. You're throwing an exception. Circuit breaker realizes, okay, so this is gone for toss. And now rest of the logic is happening. You go back here, and what do you realize this time? We tried for the second time. Observe. State is back to open. It went here, tried 2 times. Then it calculated failure rate, which is 100%. Is 100% more than the threshold? 40%. Yes, it is more. Automatically, it made a decision that I need to go into open state. It just went into that. And now it is in open state. What is going to happen in open state? Bypass is going to happen. Now, when you call that, it comes here. You're about to call the service. You don't really call the service. You go to fallback. And then you reply. And then the system just keeps tracking. For next 3 minutes, it will just keep tracking this. All the request which is being attempted, none of that is going to actually go to the third party. Everything will be bypassed directly to the fallback method. This is what circuit breaker was needed for. You don't add more load on the destination service. Take a relaxed piece for 3 minutes at least. Give some time for that service to recover. Okay, now that is awesome. And it will continue to keep doing this. It will continue to keep doing this for the next 3 minutes. And as soon as the 3 minutes is done, so let's say it will automatically move back into half open. So we want to check it till that point. Okay. So let's take a few minutes break. I think meanwhile you can mark your attendance by the time we are waiting here for maybe a couple of minutes. Let's go to the attendance. Tomorrow we will connect again. We will discuss about Eureka service registry. That is also an important feature. Definitely during interview, you discuss about these areas also. It will really help you. Okay. So Spring Cloud will give some features which are more useful for microservices. As part of that, circuit breaker and this today's topic, tomorrow's topic also you put in. Okay, let's go here. Oh, attendance was not really required. Attendance is not really required, but छोड़ देते जाने दो. Why? Because if you put these numbers, your attendance will further be affected by whatever 50-70%, and it will cause issues. So let's not track the attendance. Okay, let's not track the attendance. But all the demo pending members, please complete your demos. It is for your good only. It prepares you for interview. Okay, it prepares you for interview. So we will wait here for another 2-3 minutes. Okay, and 2 minutes, 3 minutes basic. Move to half open. Very good. Chalo, let's test further. So we will test this and then we will complete the today's session. So we went to this scenario. You try 2 times and based upon this check, both of them failed. It went here. Okay. Now just imagine if you try now 2 times. Let's say 1 time success comes. We will bring Stripe provider. 1 time it will be up. 1 time it will be down. How much is going to be the failure rate? 2 calls happened. 1 is success, 1 is failure. Failure rate is 50%. So is 50% more than 40? Yes. Again, it will go back in open. So that means if we try 2 requests, threshold will be calculated. Even though 1 is success, it is not going to go to here. The calculation will happen based upon numbers. Okay. So please be aware of that. So we need to bring Stripe provider up and both of them should be successful. Then only 100% will come, which is going to be more like different. Okay. Failure rate, success rate is going to be more. Failure rate will be 0. Right. If both of them succeed, failure rate is 0. And if it is 0, it basically comes here and then becomes a regular real-time system. Right. So let's test that scenario. So we'll come back here. Let's go to Stripe provider and start it back again. Right click, run as Spring Boot application. Okay, it is up and running. We will try both the scenarios with breakpoints. So let the breakpoints work. Go back here. In half open state, we are trying the first call. We are in half open state. We are trying the first call. Go. Breakpoint is hit. You're about to call make HTTP. You call make HTTP. Next, you call Stripe provider. Super. You got a successful response. You return. Fallback method is not called when success processing is happening. Are you realizing that? Fallback method is not called. Real success response came and you are returning it back. So if you really understand what we have built before today's session, that logic is as it is. We have not changed any of that logic. Just inside that logic, circuit breaker is taking effect. If it is success response, failure response, that's going back properly. If it is exception thrown, that is taken, called into fallback and continuing accordingly. So we need to be really careful with our testing efforts here. Okay, fine. Let's continue back. So this is first API call which we have done. Just observe, it counted one, but there is no failure count. Means one time happened, one time success. Now second request we will try once more and we will try to make it successful. Okay, so chalo, let's try it once more. 100% success we will create, so 0% failure. So we call this again. We go back here, about to call make HTTP call. Go inside this one, about to call it. You get a valid response back and then you return it back. Okay, second call has happened. Let's see what happens this time. You are here and now you are doing a refresh. Observe, you're back into the closed state. Internally it calculated, but since you moved back to the closed, it has done the reset also. It again calculated whether it was success, whether it was failed, and then it is back to closed, ready to start right from the beginning of the circle. So this is how this full loop happens. This is circuit breaker mechanism. During interview time, you need to explain these scenarios. Okay. Okay. So guys, are we clear with this? Please share your understanding score here. Then we will complete the call. Very important, guys. Technically practice the flow during interview. Tell it nice 10-15 minutes of conversation also can happen. Please share your current understanding score. Okay, whatever I coded today, I will give you the document also, the zip file also. Today itself I will upload it and share the details in our WhatsApp group. Okay, so please mark this 5, 4, 3, 2. And then tomorrow we will discuss about the second part. Actually I wanted to touch that also today, but circuit breaker sometimes for new people, beginner level, a bit it is a tricky also, right? Or a behavior like this or like this or so I did not merge two things because service registry is a big topic in itself. So we will do that tomorrow. So we did it peacefully. Okay. And guys, if you are available morning 8:30, so I don't know what you guys are doing morning 8:30 time, but if you are available, join us on YouTube daily basis. A productivity habit of daily stand up. You will automatically get a feel that we are now working as part of, let's say, corporate. So you will daily be accountable. I will be joining live Monday to Friday 8:30 a.m. You can also join, and from there you can start your day about whatever other activities you want to do. It can really help you to get more results quickly. Okay. Thank you everybody for your time. See you guys tomorrow morning 8:30 if you are available. Otherwise tomorrow morning 10 a.m. for service registry topic. Thank you all. Take care of yourself. Okay. Good guys. Take care. Bye-bye. 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 See you tomorrow. Stopping the stream. Thank you all. Keep growing, guys. Work towards goals daily. Okay. Strong preparation, strong job hunting. Bye.